Hi, good morning. Welcome to a new video here. Here we are again in Unit 4, studying scales and dimensioning. So here we have the scale 20 to 1 for this microchip. Okay, in microchips or this type of scales is when you have to enlarge the drawing to see the details of the object. Okay, a microchip is a good example because you know that inside a microchip you have electronic circuits that you may need to study or to see the details, and then you have to enlarge the object, draw the object greater than it is in reality. The shape of these enlarging scales is always like this. You have the ratio 2 1. In this case, 2 to 1. 2 to 1 means that 2 times the drawing is the real object. Okay? So you have to divide by 2 to get the real object size. Or in 5 to 1 is because the drawing is 5 times the real object. So you have to divide by 5 to get the real size, or 20 to 1 or 50 to 1 when you do a very big reduction. In this case, we have enlarging, sorry. In this case, we have enlarged the figure 20 times. So when you measure, you have to divide by 20 to get the real size. Let's see with the ruler what is the dimension of this drawing. If we place there, you have to read, you can read the you have to match the zero with this and read the dimension here. Okay, so I'm gonna match better the ruler in the right position. Now I think it's better. Okay, so when you do the reading here, you match the zero here and read here that it is 4.7.4 sorry, centimeters, or 74, wait, sorry, these are centimeters, which is 74 millimeters. Better to express in millimeters because we are talking about very small objects. When you work with chips that are very small, it's better to work with millimeters. Okay, here when you express the dimension, and now you have to calculate the size. The real size is 74 millimeters divided by 20, which is the ratio of the scale. And then when you do this, you get 3.7 millimeters. So this chip size, this chip length is 3.7 millimeters. We have calculated the real size of this. Now imagine that you have to dimension this, okay? You have to dimension the chip. You have to use auxiliary lines and dimension lines. So we use, for example, this auxiliary line, okay, like this, and now dimension line. Okay, we may need to use arrows. Normally we use arrows. And now we write, what do we write here? We write the real dimension in millimeters. Okay? And perhaps we write here all measures, all dimensions in millimeters. Okay? Later we may need to say this dimension. Okay? To do this, we need to use the ruler, okay, and dimension that. The same we can do with this track. Okay, if you want to dimension this track, knowing that the length is 14,320 millimeters, this is what we have to put. Okay, so let's do it Uh, let's clean a little bit this, okay? And we use, let's use the green color just to see clearly. Okay, we use the project auxiliary lines or projection lines. Projection lines, dimension lines, arrows, and of course you have to write here the real dimension, which is 14,320. Okay, this is what we have to do. Okay, this is how we do the dimensioning. And if you want to, you can dimension also the height with the arrows. And remember that for vertical dimensions, we need to put the real dimension in millimeters, which is 4,240, and in the in the in this position, 4,240. Very difficult to write like right here, but these are the dimensions. Okay, these are the two dimensions of this track according to the calculation we did in the other video. For this chip, you have this. Okay, so I have finished with that. Hope it was useful. And if you have any question, you have to ask me in class. See you